In this video, let's cover an example of Bernoulli's equation. We have x times dy dx minus y equals e to the 3x times y squared. Now first, we have to recognize, is it of Bernoulli's equation? Well, Bernoulli's equation looks like this. You have first order linear equation, but you multiply y raised to the power n next to f of x. And the idea is that if n is greater than 1, then essentially we can reduce this such that if we do a u substitution where we let u equals y to the 1 minus n, then this will reduce to a linear equation. Okay? But first, is our equation in that form? Well, in order to see that, first we have to divide an x over. Now we can see that p of x equals 1 over x, f of x equals e to the 3x over x, and y squared here is like the y to the n. So n equals 2, and further u becomes y to the negative 1. Taking the derivative, du equals negative dy over y squared. Now can we sub these in? Not quite yet. First, we have to divide the y squared over. Right away, the y and the squared in the denominator cancel. Rewriting this, we get. And now, if we take a look at y squared dy, we see that we can substitute the negative du, where the negative came by dividing it over. And for 1 over y, we can see we can just substitute a u. Now we get the following. And now this equation is in the form of a linear equation, so we have successfully done our reduction. Now, recall the purpose of a linear equation is that you want to have the left side look like a product rule, in order so that you can undo the product rule and solve for it. So we go ahead and proceed with that. We multiply an integrating factor mu on each side, and now we see that in order for the left side to be a product rule, mu times 1 over x has to equal mu prime. In other words, du or d mu over dx has to equal mu over x. Separating, this is a separable, so we can separate. Having the mu and the x's on each side, integrating, we shall get this. Taking e to the power of on each side, it undoes the natural log, so we have mu equals c times x. And now that we have solved for mu, we can essentially plug that in and undo the product rule. So we do that. And now, if we take the derivative on both sides, or sorry, excuse me, if we take the integral on both sides, and we divide the mu over, we get the following. And now I'm going to plug in for mu, and we have this. Now, the constant c right away cancel. The x's inside the integral cancel. And we're going to go ahead and combine c1 over c into one constant. And we also went ahead and solved our integral. It became e to the 3x over 3. We plug back in for u. We got this. Now we pretty much have the solution, but I want to simplify it such that we have the constant by itself. So we can add the 1 over 3x e to the 3x over, and then we multiply x on each side. We go ahead and cancel the x's, and now we have this, and this is our solution.